Hello. Today we're going to be looking over the sign test, normal approximation to the binomial, and we'll be looking at an example of this. The statistic instructors at Camosun College would like to know if students have better test scores on the first midterm compared to the second midterm. At the end of the semester, the instructors looked at 15 of the students' midterm number 1 and number 2 test scores. Conduct a test of hypothesis to determine if there is a difference in the test scores from midterm number 1 and midterm number 2. And we'll be using the 0.05 significance level. So the first step in this question is to state the null hypothesis and the alternative hypothesis. So H0 is pi equals 0.50, which means there is no difference in test scores, and H1 equals pi does not equal 0.50, which means there is a difference in the test scores. Step 2 is to select the level of significance. This was previously stated in the problem as 0.05. So step 3 is to select the test statistic. We will be using the Z distribution. From the sample, the number of pluses that are in the sample will determine which formula we will be using today. And since the number of observations in the sample, which is 15, is larger than 10, the normal distribution can be used to approximate the binomial. Step 4 is to formulate a decision rule. For a two-tailed hypothesis test with 5% significant level, the critical Z values are negative 1.96 and positive 1.96. So with this, we can formulate a rule to say reject the null hypothesis if the Z statistic is less than negative 1.96 or greater than positive 1.96. We then look at the sample and make a decision. So here we can see that there are 15 observations as well as the results from the midterm number 1 as well as midterm number 2 for 15 students. And we take the first midterm number 1 and we subtract it from midterm number 2 to result in the sign. And it shows here that there are 11 pluses and 4 negatives. So from the sample, there are 11 plus signs, and since 11 is greater than n divided by 2, we can use the following formula to calculate Z, which is sign test when it's n greater than 10 and plus signs are more than n divided by 2. We will use this formula here. And so this is conducting the formula. So we're going to take 11 minus 0.50 minus 0.50 times 15 and take all of that and divide it by 0.50 times the square root of 15. And the next step is to just break that down. So we'll get 10.5 minus 7.5 divided by 0.50 times 3.87. We can then work all that out and get a Z of 1.549193338. We can round that up to just 1.55. And now with this result, the computed Z of 1.55 is within the critical value of 1.96. So we then fail to reject the null hypothesis of no difference at the 5% significance level. And step 6 is to then interpret the result. So the data provided gives us evidence that there is no difference in test scores after the second midterm. We can conclude that the students did equally or almost equally well on the second midterm compared to the first. Thank you.